Hello, Dr. J here with another exciting video lecture. Today I'm going to be talking about lipid absorption and processing. Now we know that fat digestion begins in the mouth thanks to the enzyme salivary lipase, and that it continues in the stomach and in the duodenum thanks to gastric lipase and pancreatic lipase respectively. Now we're going to talk a little bit about bile and how bile emulsifies fats. We'll see that the tiny post-emulsification droplets are called micelles, which are absorbed into the small intestine cells known as enterocytes. Within those small intestine cells, there's some biochemistry going on, and the fats are reshuffled into a different package and secreted as chylomicrons. These lipoprotein complexes will transport fats through the bloodstream safely without those little particles of fat sticking together and forming some big fat embolism. The liver plays an important role in all of our nutrient absorption, and fat is no exception to that. The liver repackages these lipoprotein shells into VLDLs, LDLs, and HDLs, and you probably recognize those terms if you've ever had your cholesterol tested. The reason being that there's a high correlation between elevated LDL levels and the development of atherosclerosis, heart attack, and stroke. Here's an image that just reminds us how important bile is. Bile is, of course, made by the liver and then flows down through these hepatic ducts into the bile duct. And during the intestinal phase of gastric function, a hormone called cholecystokinin stimulates contraction of the gallbladder, and then the bile is squeezed out. Bile acts like soap in its ability to dissolve the fat. So what we see here on the left side is a fat globule, a phospholipid here called lecithin, and the all-important bile acid. If you notice here, the blue region of the bile acid is hydrophilic, which aims outward into the watery solution of our digested food, and then the white inner portion, being fat-soluble or hydrophobic, will easily wrap against these tiny microdroplets. So this is a process called emulsification, where we shatter a big fat globule into many microscopic fatty droplets. These can now be absorbed into the enterocyte, and that's what we see here in this figure. The fat-soluble micelles are absorbed into the enterocyte, where enzymes begin to disassemble their components, and we see fatty acids and monoglycerides. These are the building blocks of the all-important triglyceride. This is nature's long-term energy storage molecule and what ends up in our fat cells. Additionally, within the enterocyte, we see phospholipids, cholesterol, and there would also be our fat-soluble vitamins and any fat-soluble toxins that are in the environment. These come into our body through this mechanism as well. So the enterocyte then secretes those little packages called chylomicrons. You can see them bubbling off from the Golgi and being exocytosed into the lacteals. This green structure is a modified lymphatic capillary called a lacteal. So now these dietary fats are inside the body and they flow through the cisterna chyli and thoracic duct into the bloodstream. So now we have chylomicrons in the bloodstream. Enzymes are going to be pulling out triglycerides and depositing them into my fat cells. So within hours of eating a fatty meal, if you had a very high-tech scanner, you could see that I'm measurably fatter already because I'm depositing those triglycerides into my fat tissue. Those chylomicron remnants then go to the liver, where they're repackaged, recycled, and sent back out as VLDLs, dropping off more triglycerides in the fat cells. And once they've been stripped out, they will contain mostly cholesterol. At this point, we change the name and we call these LDLs, that's low density lipoprotein. And these are, again, a high risk factor for the development of atherosclerotic plaques. Meantime, the liver has produced empty HDL shells. These are high density lipoprotein. These are fundamentally different from the other complexes because they have the ability to go out into the tissues, capture lipids, and bring them back to the liver, whereas VLDLs and LDLs are taking fats from the liver and delivering them out to the tissues. Here we see on slide number 8 a comparison of those different lipid delivery vehicles. That's really what these are. We call them lipoproteins. Clinically, sometimes we talk about them as being good cholesterol and bad cholesterol. I call them safe, portable lipid delivery vehicles, right? They're safe, meaning that they're not going to start to stick together and form a big fat embolism. They're portable because they flow through the bloodstream, and obviously they're delivering lipids from one point to another. And so we see here, starting with the chylomicrons, which are mostly triglycerides, we have a lot of good long-term energy here that needs to be stored in our adipocytes. Then the liver is going to be producing VLDL, very low density lipoproteins. These are also mostly triglyceride, but they have a much lower percentage. They become LDL cholesterol, LDL, low density lipoprotein, which is mostly cholesterol. Look at this, it's only down to 6% triglycerides. Fundamentally different in many ways, the high density lipoprotein molecule is mostly protein. This is the only one that can scavenge, grabbing fats and cholesterol in the peripheral tissues and bringing them back to the liver where they can be recycled once again. I hope this helps.